In the previous tutorial, /post/rust tutorial concurrency/, we learned threads, channels, and mutex for concurrency. Now we learn async/await, a different way to handle concurrent work. Let's break it down. Setting up Tokio Rust standard library provides the async and .await keywords, but it does not include an async runtime. You need a crate for that. The most popular choice is Tokio. Your first async function, an async fn, returns a future. The function body does not execute until you .await the future. The Tokio main macro sets up the Tokio runtime and runs your async main function. Without it, you cannot use .await in main. Simulating async work. Let us simulate slow operations with Tokio time sleep. Notice Tokio time sleep is an async sleep. It does not block the thread. The standard std thread sleep does block the thread. Never use it in async code. Sequential versus concurrent execution. Sequential, one after another. This waits for the user request to finish before starting the order request. Total time is the sum of both waits. Concurrent, both at the same time. Tokio join. Spawning tasks with Tokio spawn. Tokio join runs futures on the same task. Tokio spawn creates a new task that runs independently on the Tokio runtime. Tokio spawn versus Tokio join. Racing futures with Tokio select. Tokio select waits for the first future to complete and cancels the rest. The 50 milliseconds sleep finishes first, so select. Async error handling. Async functions work with result just like regular functions. The operator works in async functions too. Async blocks. You can create futures in line with async blocks. Async blocks are useful when you need to create a future without defining a separate function. They capture variables just like closures. Shared state. In async code to share state between tasks, use arc Tokio sync mutex t Tokio sync mutex versus std sync mutex. Rule of thumb: if you need to hold the lock across and .await point, use Tokio sync mutex. If the lock is short, no .await inside. std sync mutex is fine and faster. Async versus threads. When should you use async and when should you use threads? Use async when you have many I/O bound tasks, network, files, databases. You need thousands of concurrent operations. Each task spends most time waiting. Use threads when you have CPU-heavy work, math, parsing, compression. You have a small number of tasks. You need true parallelism on multiple cores. Memory comparison. A thread uses about 2 megabytes of stack memory. An async task uses about 200 bytes. Common mistakes. Mistake 1. Using std thread sleep in async code. Mistake 2. Forgetting to .await. The Rust compiler will warn you about unused futures. Always pay attention to those warnings. Mistake 3. Blocking the runtime. Testing async code. Use Tokio test instead of test.